Hi, I'm Mark Gislow. I teach geography and geospatial technology at Lakeland Community College, which is located in the Cleveland, Ohio area. Today, I will present to you, wait, how much land is managed? Remote sensing students have the answer. And this was from an experience in a remote sensing class I taught in the spring of 2019. We have 4 major areas of focus in our department: geography general education, geospatial technical skills, experiential learning, and career development. And I think the most exciting thing about teaching in this program and teaching in this department and in this discipline is mixing those 4 things together in different ways in different courses. Remote sensing is an exciting class to teach, in part because it demands so much of the students and demands so much of the instructors in terms of being able to reconcile the way we think about data, and students really for the first time in terms of our program anyway, getting into much detail about how they understand, interpret, and use imagery within the context of GIS mapping. We adopted the textbook Imagery in GIS for the first time in spring of 2019. And the 4 content areas of this textbook really match the goals that we have for students in terms of how they learn to use imagery in the context of GIS. Most of our students will be going out and working for engineering firms, for government, for nonprofits, doing things like watershed mapping, stormwater mapping, utility inventories, and things that basically require specific applications to imagery use, but that also require that students have the theoretical underpinnings to understand imagery and also a deep understanding of the processes of analysis that relate to that imagery. I particularly like the way the textbook deals with classification schemes. And so there's a whole chapter devoted to classification within imagery and how classification schemes can be used to derive classes for particular projects or for use for more general purposes. So we do a couple of labs that integrate the National Land Cover Database before we started working on the project. And this helps students understand that just because they get an output in ArcGIS Pro, or at that time we were using ArcMap, doesn't mean that it's a legitimate output that they can do something with unless they understand what they're doing with it. And so by working on classification schemes, it's a great way to bring together the way they interpret and understand the data in the context of their projects. We had a small class that semester with only 5 students, plus the work from our GIS lab assistant who had just taken the class a year previously. What we set out to do was to determine the answer to this question: how much land in a park system is managed versus unmanaged? And so we looked at the Geauga County Park District, which is the county right next to where we are here in Lake County, Ohio. And we wanted to add some information to a problem that they had had in estimating how much of their land was, quote, managed. And they had estimated that 3% of their total land area was managed, but they didn't really have a good systematic way of coming to that determination. So we wanted to put GIS and remote sensing to use to help them determine that. We had worked with the park system previously on some projects, so we had a pretty good understanding of what GIS data they had and what was missing. I'm going to take you now to the story map students created, and I want to encourage everyone to look at the story map on your own time as well. So the objective again was to determine the amount of land that is managed versus unmanaged in the park district. This is the classification scheme the students ended up adopting for use once we had already used the National Land Cover Database to categorize land into big categories. Then we wanted to go a little bit further than that in our classification. We used 1 meter NAIP imagery, National Agricultural Imagery Program data, 4-band as our main data source, plus other orthophotography from the state of Ohio and lots of ground truthing field data collection and integration of the mapping students did hands-on in the field using Collector app, Survey 123, and so on. We did unsupervised classification using standardized methods across all parks. Each student mapped 3 or 4 park units. They all downloaded individual tiles for those units, mosaicked where they needed to, clipped them, ran raster statistics, and then processed that data. They came out then in the end with maps that look something like this. This would be a good example of one of those maps. that then put the land cover into the categories for the National Land Cover Database. Manual classification then was used to clean up the data, to provide missing data. For example, the park system did not have any road layers, so we created them. We created them basically through either on-screen digitizing, using a combination of different types of imagery, or by going out in the field, riding bicycles, walking trails, walking roadways, and doing all those kinds of things. Students slogged around in wetlands, they became familiar with the data, and they identified lots of challenges. For example, there were parks where the parcel boundaries didn't match what we expected to see once we got into the GIS data. So the students got into the parcel mapping history and got a better understanding of where there were either updates needed or where other issues existed. One of my favorite aspects of this project is that students went out and looked at all kinds of different conflicts where we had mixed pixels, we had poor interpretation of things because of wetland conditions, lots of wetlands that were even being mowed that probably shouldn't be mowed, where students found vegetation had died. It does this. Imagine what that does on the imagery. And the students have to look at the imagery from the point of view of why is it interpreting it that way when that's what you have on the ground. This is a good one here where this is a wetland area, but it actually is mowed. It's in a low-lying area. So having more GIS data might help the park system make better decisions about how it uses, how it manages that land, and can be used in their, in their overall management processes. The overall findings: students found that 16% of the land can be classified as managed according to unsupervised classification. But that's before we go into it and look at all those challenges where we have misinterpreted pixels and mixed pixels and all kinds of other issues going on. And so from their field work and their manual classification process, the students ended up with 9% managed, which we think is a fairly accurate number. We were able to account for how much land is mowed. The park now knows how many acres it has that are mowed, how many acres are covered with trails, how many are covered with parking lots, roads, structures, and so on. So it gives us a good sense of then how to bring that information together in new ways, and also students had to go out and do lots of field reconnaissance and collection. They went out in pairs or 2 or 3 students at a time and basically did a lot of data collection from that. They presented their results at the Northeast Ohio GIS Symposium in May, which paired up with final exam week, so that conference became the final exam. Each student presented a poster, and then the group presented the story map. And that's all I have to say. Let me know if you have any questions, and I'd like to hear if there are any comments or questions. Thanks for your time.